Hello friends, I hope you all are well. Today in this video I am going to explain the image formation, the different types of image formation by a concave mirror. So I hope that you might have subscribed my channel. If you have not done, don't delay, because your subscription will help you to get the information as earliest. At the same time, you can get our videos consistently. So our topic is formation of image by concave mirror. In this video, I shall explain how the images are formed when the object is placed at different positions in a plane mirror. When an object is placed at different positions in front of a concave mirror, not plane mirror, in front of a concave mirror, an image is formed. That image is formed when at least two reflected rays meet or appear to meet at a point. That means, for example, this is a concave mirror. This is one light ray coming from this object. One more light ray coming from this object. For example, this is reflecting like this. This is reflecting like this. So they are meeting at point. So when at least two reflected light rays meet at a point, it makes an image. So to find the position of the image to find the position of the image formed by a concave mirror, we have to draw at least two light rays, two reflected light rays, those light coming from the object. So for that purposes, we have to know the path of the light rays after the reflection. Those light rays coming from the object, how they are reflecting, what is the path of its reflection, we have to know. So for that purposes, we have to know the rules for getting images formed by a concave mirror. So certain rules I shall tell, through which you can know the behavior of a light rays. Then it will be easy to draw the ray diagram. At least if you can remember two rules, that rules indicates the behavior of the light rays after reflection by a concave mirror. So at first I would like to explain the rules for getting images. Rules for obtaining images by a concave mirror. What are the rules you see? Rule number 1. See, suppose this is the concave mirror. N is the size of the mirror. Here P is the pole of the mirror. This is the principal axis. This point is the center of curvature. This is the focus. Okay? Suppose I gave its name The principal axis itself represents an incident ray also. See, okay. Now, suppose a light ray coming parallel to the principal axis. I give its name, suppose A, and it incident at the point B. Then it reflects through the principal axis. This is the first law. I can say that ray of light parallel to principal axis of a concave mirror passes through principal focus of the mirror after reflection. See here, a ray of light parallel to principal axis passes through principal focus after the reflection. After reflection, it is passing through the principal focus. So, from this rule, we came to know if a ray comes parallel, it will passes through the focus. Comes parallel means comes parallel to the principal axis. This is the first rule. Second rule. So, this is rule number 1. What is second rule? Rule number 2. See here. Suppose this is the incident ray. This is the reflected ray. If a ray of light comes through focus of the concave mirror, it moves parallel to the principal axis. Principal axis after reflection, just opposite to the first rule. See that if a ray of light comes through focus, it is coming through the focus, it is incident at the point B. Okay, after that it is reflecting, which is traveling parallel to the principal axis. So this is the rule number 2. Next, what is rule number 3? Rule number 3. Center of curvature. This is the focus. So this is the pole of the mirror. Concave mirror. Suppose XP is the pole. Principal axis. This is principal axis. Center of curvature, focus. Now, suppose a light ray coming through the center of curvature after incident, it will reflect back along the same path. That means, you see that in my earlier video I explained that the line joins the center of curvature to any point on the spherical mirror is a normal. This is the incident ray, this is also normal. That means here angle of incident is equal to 0. So it follows the laws of reflection. So the angle of reflection also will be equal to 0. That means how the light ray is coming, it is also going back after the reflection along the same path. So third rule, I can say that a light ray coming through center of curvature is reflected back along the same path. How it comes? It goes along the same path but in opposite direction. So this is the third rule. Next, fourth rule. Rule number 4. See here. A ray of light which incident at the pole, it reflects making same angle with the principal axis, because this is the incident ray, this is also normal. The principal axis itself is a normal, because this also joins the center of curvature to any point on the spherical mirror. So this is the angle of incident, this is the angle of reflection. Both are equal. So fourth rule, I can say that a ray of light incident at the pole reflects by making same angle with the principal axis. A ray of light incident at the pole reflect by making same angle with the principal axis. These four rules I said, it will help to know the path of a reflected light rays. From these four rules, at least two rules, if you take, it will help you to draw the ray diagram easily. For that purposes, these four rules represents behavior of light rays after reflection. The common thing already you know that it follows the laws of reflection. That means angle of incidence is equal to angle of reflection. Any cases if forgotten, we can implement our common rule, angle of incidence is equal to angle of reflection. But if you know these rules, definitely it will help to draw the ray diagram more easily. So let us go to discuss how the formation of image taking place by a concave mirror. So I can say that formation of different types of images. Formation of different types of images by a concave mirror. Here, the image formation, the type of image formation depends upon the position of the object in front of the concave mirror. What are the possible position of the object may be? So, position of the object may be between P and F, pole and focus. It may be at F, at focus. It may be between F and C, focus and center of curvature. It may be at C. It may be beyond C. It may be at infinity. Okay? So, these are the 6 possible positions of the objects I have taken. So, let us start the formation of image. See, this one is the mirror. Suppose this is the pole, this is the focus, this is the center of curvature. XP is the principal axis. Okay? Now, we will take the extended object or enlarged object, because in my previous video I said in this topic we can use 2 types of object. One is the point object, one is the extended object. So throughout my diagram I shall use the extended object. First one is the object between pole and focus. This is the pole, this is the focus. For example, this is the position of the object. OB is the object. Now I shall draw a light ray which comes parallel to the principal axis, because I know that the ray which comes parallel to the principal axis after reflection, that means it will be reflect through the focus. So directly I can draw, because I know that any ray comes parallel to the principal axis. After reflection it will pass through focus. Next one, I can draw in different ways. What are the different ways? For example, okay, I am taking this one. So this is the incident ray, this is the angle of incident, this is angle of reflection. That means if it incident at the pole, it will reflect making same angle with the principal axis. So in this case what will happen? If I extend it, so it is meeting, so perfectly not coming. Okay, see here. This is the image. How the image format? This is reflected ray, this is reflected ray. This is our eye position. Okay? Now, the reflected ray seems coming from this point, means from back side of the mirror. This type of image is called the virtual image. You observe the size of the image bigger than the size of the object. The image is formed behind the mirror, virtual, erect and magnified. So I can say that the nature of the image will be first position of the image behind the mirror. Behind the mirror. Second one is the virtual. It is not the real image. Light rays not really meeting. It seems that these reflected light rays are diverging from this point. Suppose this is the O dash, this is the B dash. Image. So virtual. Third point is erect. Standing as it is. Arrow mark upwards. Here also arrow mark upwards. So behind the mirror, virtual, erect. Fourth one is the magnified. So this is about the characteristics of the image formed by a concave mirror when the object is placed between pole and focus. This idea we can apply in some cases like dentist use one mirror, head mirror. That mirror he focuses towards your teeth and he placed the mirror. However, your teeth will be between pole and focus. As a result, the image of the teeth will appear enlarged. At the same time, dentists also use one headlight to see properly. In that headlight, the position of the light, source of light at the focus. So, in the reflector of his mirror, the light rays comes from the focus. Suppose this is the focus. Light rays will come from the focus. It will fall here. After that, I said that those coming through the focus, they will move parallel. So, he can see the position of the teeth properly because all light will focus there. Okay? Or if the light rays comes parallel, the entire light will focus at the teeth. That means he can see it clearly. Okay. So these are the applications of a concave mirror. Okay. Now some more applications later I shall tell you. So image formation when the object is between pole and focus. Second one, at focus, at F. See here. So this is the pole, focus, center of curvature. This is the principal axis. Suppose the object at F, So light ray comes parallel. It will reflect through the focus. Already we have studied the rule I said. Goes through the focus. Okay. Now one more light ray I am taking. Suppose I am taking like this. You can take like that. That means it is coming through the center of curvature. It touches this position. So it goes back along the same path but in opposite direction. this is the incident ray, this is the reflected ray. This is incident ray, you can consider this is the reflected ray. So how they are moving? They are moving parallel. You can draw the light ray from here to here, here to here also you can draw. If you wish, suppose you want to draw, this is the focus, this is the center of curvature, suppose this is the parallel ray, it will passes through the focus. If you want to draw from here, you can also draw like this. So this one also will go parallel. See, this is the incident ray, this is the reflected ray, this is the incident, this is reflected. Okay. So I said that I am applying two rules here. I have to know the path of a reflected light rays. So either like this or like this, you can also draw, not matter. So what about the nature of the image? See that where the image formed? Image formed at F. Sorry, at infinity. Image formed at infinity, because these are the parallel rays. They won't meet. Let it meet at infinity. So at infinity, what type of image? Real image, because when the light rays meet really, they make the real image. In fact, we won't see the image. Nobody has seen the infinity. But we say that suppose infinity somewhere they meet, that means the image will be real. It will be highly magnified and inverted. All these real images are inverted. If they are meeting at infinity, so definitely they will make a highly large image which is inverted. So this is the characteristics of the image formed by a concave mirror when the object at a focus. So the image will be formed at infinity. We can't see it. Okay. But if I say that infinity is real, highly magnified and inverted. Third, between F and C. Between F and C. The object between F and C. So this is the mirror, pole, focus, center of curvature. Now the object is between F and C. Between F and C. That means the object is here. Any point between F and C. So first I am drawing parallel, because I know if it comes parallel, it will go through the focus. So this is the incident ray, this is the reflected ray. Next one, I am drawing this one. So this is the angle of incidence. So it will go like this. So how the image is formed? The image is formed beyond the center of curvature. So I can say that nature of the image, how the image is. It is the position beyond C, beyond the center of curvature. Next one, real, inverted and magnified. You see size of the object. This is OB object. I can say this is O dash, B dash is the image. It is enlarged. So beyond C, real, inverted and magnified or in last you can say this is the characteristics of the image when the object is placed between focus and center of curvature of a concave mirror. Next one, at C. We see at C. At C. So this is the mirror, pole, focus. This is center of curvature. So object is here. This is okay, object center curvature, OD is the object. So it will pass through the focus. We know that if incident ray comes parallel to the principal axis, the reflected light will pass through the focus. Next one. Suppose it is meeting at the principal axis. Now see here, incident ray, this is reflected ray. This is the incident ray, this is the reflected ray. Both are meeting at this point. That means this point is the B dash. Okay? So this is the image. So I can say where the image were made? Image at C. That means image at center of a curvature. Real inverted same size, real image, inverted image and same size image. So next one is the beyond C. Beyond C. The object beyond C. So this is suppose mirror, this is the principal axis, this pole, this is center of curvature. Suppose the object is beyond center of curvature. Now the light ray comes parallel. So definitely it will passes through the hit at this point B, it is passing through the focus. See it. Next way, I am taking it from here. This is the incident ray, this is the reflected ray. This is the normal, this is the incident ray. Angle of incident, angle of reflection, both are equal. All time, all cases, all rays will follow the rule, no doubt. Now, where they are meeting? They are meeting at this point. OB is the object, O dash, B dash is the image. So, what are the characteristics of the image? Where the image were made? Between F and C. Between F and C. Real image. It is inverted and diminished. Diminished means small in size. Size of the image is smaller in comparison with the size of the object. So this is the characteristics of the image when the object is placed beyond the center of curvature. So next one is the at infinity. object at a infinity. Position of the object. Okay. Now, this is the focus. This is the center of curvature. This is the pole. Object at infinity. Suppose the light rays comes like this. It comes like this. So these rays are parallel to the principal axis. They are coming from infinity. I have taken them parallel. Those light rays coming from the sun, we consider they are parallel because they are also coming from far away. So these rays will meet at this focus. This is the reflected ray, this is the reflected ray. Suppose this is the pole, this is the focus. I think it will not appear here. See here. This is the focus, this is the center of curvature, this is the pole. Okay? Suppose light ray came like this, no matter. This is incident ray. We can draw one normal. They will also reflect. Sorry, it will not go through the focus. It will follow the law of reflection. Suppose it came like that. Okay? And one more ray came like that. Okay? Suppose one more ray came like that. It will also reflect. Suppose the reflect like this. Okay? So where they are meeting at the focus. The image becoming very small. In this figure, you see that the reflected ray coming from far away. Sorry, the incident ray coming from far away are taken parallel rays. They are passing through the focus. So the image formed here. The characteristics of the image will be image where it is formed at F. Image is at F. They are really meeting. So it is also real image. Real. Highly diminished. Means very, very small. In this case, it is pointed image, you can say. The image is like a point. But since the light rays are meeting, so definitely it is a real image. And all real image, we say it is inverted. But since it is a point object, point image, that's why not mentioned inverted. So these are the ways we can get the images when the object placed at different positions. Okay? So next point I want to say that how to find focal length of a concave mirror easily. How to find focal length of a concave mirror approximately. Okay, how we find out? We'll take a concave mirror. Suppose this is the concave mirror. This mirror will focus towards the sun, and in front of the mirror we place one piece of paper. We have to adjust the position of the piece of the paper. However, the image of the sun will form on the paper or skin. So we have to adjust until getting a sharp image of the sun. a sharp point will come. That position is the position of the image when the object far away like the sun. So suppose the paper I placed here, I got the image of the sun very small in size. So this distance will give the focal length. This distance will give the focal length, because we know that light rays coming far away parallel, and the parallel light rays after reflection they meet at the focus. That means I have placed the screen or the paper exactly at focus. So by measuring the distance between the pole and the paper or the screen, I can get the focal length of this concave mirror, but it is approximately. So like this way we can find the focal length of a concave mirror in easy way. So next is the applications or uses of a concave mirror. So some of the important uses of concave mirror. Uses of a concave mirror. See here. So we use concave mirror as the reflector of a headlight. Reflector of the headlight of the vehicle. In vehicle headlight, in that headlight backside one silver, looking like silver, polished car surface will be there, and the ball adjusted in such a manner at the focus. So when light rays comes from the focus, it will fall on the reflector. Reflector will reflect the light to long distance with the parallel. Okay? Because we know that when light comes through the focus, after incident of the concave mirror, it moves parallel to the principal axis. So in case of the reflector of a headlight of the vehicle, we use concave mirror. Again we use concave mirror used by a dentist. As a head mirror or a headlight. Two purposes we can use. Head mirror to see the size of the teeth in bigger. Headlight to focus the more light to a particular point. So dentist can use. Next one, we can use it as a shaving mirror. Shaving mirror. What shaving mirror? But our face should be very close to the mirror. If our face should be very close, that means between pole and focus, then the image will be formed bigger in size. Because in first case here I explained, if the object between pole and focus, the image will be behind the mirror, virtual, erect and magnified. So if we use as a shaving mirror, our face should be between pole and focus, then the image will be bigger in size. It is a virtual but erect image, which one will be convenient for shaving purposes. Except that some other uses are there. One is we can prepare the solar cooker. Solar cooker. So how it is possible? Suppose you can take one old dish, what we are using for television purpose, telecasting purposes. Your dish antenna, suppose old is there, you can take it and you can take plane mirror. But that plane mirror you have to cut in the shape of the triangles. However, its radius should match with the circular disc. That means by the help of plane mirror, we can prepare a concave mirror. I want to say that one. Then, now it will be converted into a concave mirror because concave mirror easily not available. It is available but not in our hand distance. So, with the help of plane mirror, by cutting it in the form of the triangles, we can arrange one concave mirror. Then, if it is a concave mirror, there will be focus. You might have seen in old antenna, one receiver will be there. That receiver exactly fitted at the focus. So, at that focus, we can arrange some pot or we can arrange, however, we can place our pressure cooker. That means, when the light rays will come and fall on this concave mirror from a large distance parallel, all the light rays will focus at the point, means all the light rays will meet at the focus. So at that point, if we can arrange the cooking vessels, then all the light rays or the heat will concentrate at that point. That means we can use it for solar cooker purposes. So these are the major applications of a concave mirror in our day-to-day life.